So this is session 4AQ, so please do make sure you're filling out feedback with that session ID, and we'll bring that up again at the end and with a QR code as well for you to fill out the feedback from. So we have Brian from IBM USA, who's going to be talking to us about getting started with Ansible. So I think there have already been a few Ansible sessions so far this conference, but I think this is going to be a really good, handy one for getting started and actually delving into some demos and showing you how you can get going with it. So really looking forward to it. If you can all make sure you post any questions to the chat, and then I'll ask it to Brian as well. And I think with that, over to you.
Great, thanks, Sophie. So my name is Brian Pignarchin. I'm one of the architects for the Red Hat Ansible certified content for IBM Z offering, and I'll talk a little bit more about what that is if this happens to be the first Ansible session that you're joining during this event here. But mainly what I'm going to be talking about today is, as Sophie mentioned, really just how you can get started. So I'll briefly touch on the high-level overview of what Ansible is and some of what we're contributing in that space in terms of Ansible content for IBM Z, and then I'll dive into several demos where we can start talking about how you can get hands-on and some of the resources that are available for you to get started. So some of the standard GSE slides that you've likely seen before and some of the other presentations here, and then let's get to the meat of it. So Red Hat Ansible, there's a lot of different components when we talk about Ansible, and primarily the main enterprise solution that we have here in that space is Red Hat Ansible Automation Platform. And what that is a set of capabilities that enable Ansible automation for your enterprise. So there's a lot of different aspects and functions and features that are provided by Automation Platform, a lot of services that are hosted with that offering, but we'll talk about also focusing on sort of where it is that we're providing content here. So some of the hosts that you have available are things like Automation Analytics, access to Automation Hub and certified content, as well as additional options for how you want to host your infrastructure and your automation infrastructure and make that available across your enterprise. So two other main key components, as you can see here in the middle, as well as the bottom row, there's Ansible Tower and the Ansible Engine. And Ansible Tower is one of the main tools, a graphical interface that allows you to scale and manage your automation and make those available across the different teams as you're taking some of these playbooks and automation that you're developing at a lower level and wanting to make them available across other teams. So Ansible Engine is sort of the base engine and set of libraries that runs some of the Ansible automation scripts, and we'll talk a little bit more about that. So this is a little bit detailed, a little bit lower level on some of those pieces and how they fit together. So as you can see, Ansible Tower is that overarching tooling that consumes firstly Ansible playbooks, and that's what are essentially scripts that you're writing your Ansible automation in, and that's all based in a YAML syntax that's intended to be easy to consume, easy to read, and generally easy for many folks to be able to pick up. One of the main benefits and one of the reasons why we decided to start heavily investing in Ansible as well is one, it is a market dominant automation platform today. And one of the reasons for that is because of its ease of use and because of the flexibility that it has for working across various platforms, various hardware. You can essentially automate pretty much against anything that has a SSH endpoint, or even if it doesn't, when we start talking about, things like network devices or other types of devices where there's specific Ansible modules and plugins intended to interact with those pieces of hardware. So that's, again, one of the values of using Ansible is that you can have a consistent automation framework across all of your platforms, across all of your hardware and your enterprise as a whole. So now all these Ansible playbooks, what they're leveraging at a lower level, the different components that you'll see are some of the things in the green boxes, which are plugins, modules and tasks, as well as roles. Those are all different ways of invoking tasks against your target system. So plugins and modules are essentially very similar depending on sort of what functions they're making available, whether they're extending the Ansible engine itself or actually intended to interact with a particular product or system. So that's where, from our standpoint, we're providing a lot of different modules and roles for the IBM Z platform to be able to interact and do some basic capabilities there. And all of this is all packaged up in what are called collections. So on that right-hand side there, collections are essentially a way for distributing Ansible content, and essentially as a simple tarball with some additional metadata that allows you to be able to install and manage those things in a consistent way across your what are called control nodes, where your Ansible automation is running. So Ansible collections, those are the main way for not only us, but just folks in general in the Ansible community to be able to distribute all the different Ansible content that they're creating. So just to give you guys an idea of all the different types of integration that we have available for IBM Z, you can see here again, like I mentioned, we're working on providing a lot of base capabilities as well as integration to different middleware. So highlighted here are some of the middleware products such as IMS, Kix, DB2, MQ, and ZOS Connect that we have various levels of, whether it be Ansible collections or Ansible sample playbooks, which is what we're going to go through today. Sample playbooks in our GitHub repository for interacting with these subsystems, as well as various other products such as system automation, ZHMC, ZOSMF. And the key takeaway here is that while we're working hard on providing a lot of existing content and collections for users like yourself to be able to start using Ansible with IBM Z quickly and easily, again, harping back to the flexibility that Ansible has with some of the general modules that it has, we can already do a lot against some of these products, even if there isn't a dedicated, Ansible collection or Ansible playbook out there for it. The main mechanism for Ansible interacting with any system, right? Again, like I mentioned, is via SSH. So as we know, right, ZOS, we have SSH available as well. So once we are accessed into Unix system services through SSH, we're able to run a number of different commands, and we can run JCL, we can interact with batch interfaces or any other tooling that has command line interface tooling based in USS. So that opens up a whole lot of possibilities, even if you don't see a specific collection available. That's, in particular things, the same approach that we've taken with, DB2 or WAS Liberty or ZOS Connect, right? A lot of that is very USS based. So we're already able to do, cover a lot of use cases there with the collections that we have today. So let's talk a little bit about some of the use cases, specifically ones that IBM Z customers have. And these are all generally use cases that also Ansible touts as, what they can do across all the different platforms, right? And essentially those use cases apply to IBM Z as well. And I'll quickly just run through some of these. Like I mentioned, provisioning and maintenance, anything from provisioning subsystems and middleware or provisioning application environments, rolling out service and fixed packs across various subsystems. That's a particular area of interest. To mention, all of these we've been working a lot with various customers, so that we've got customers backing all of these, interested in all of these various use cases. Configuration management, that's one that Ansible's declarative task approach and YAML syntax really caters well to that, because essentially bringing in the best practices around configuration and infrastructure as code, being able to manage not only system configuration, but as well as middleware configuration like ZOS Connect, server configuration files, or those type of configuration within, leveraging SCM as well, and some of the best practices around having some of that control. Security automation is another interesting one that has a lot of interest, specifically things like SSL, certificate renewal, and taking not just the process that we have within ZOS and that manual process, but also tying that together with the same processes or similar ones that they have across other distributed platforms, right? And consolidating that to be able to kick that off consistently, as well as tie together some of the third-party tooling, such as Venafi or some others that might be used for managing some of their certificates, and really combining that into a higher level process that folks have higher visibility and control over. Obviously, CI/CD and application deployment is a big area where automation is key. And Ansible certainly has tons of integration, whether it be with other open source CI/CD tooling, as well as even the ZOS tooling, things like Urban Code Deploy, or just, again, interacting with the middleware directly and being able to run various types of commands against Kix or IMS to be able to do application refreshes and deployment and things like that. Orchestration is another sort of a gateway use case for a lot of people getting started, which essentially means, first off, we can orchestrate, again, across various different platforms, right? And start thinking about how we can start combining some of these disparate automation processes into something that, again, makes more sense at a higher level once we start consolidating them, such as like the certificate renewal process use case that I mentioned earlier, but also orchestrating existing automation, right? Whether it be JCL or Rex or ZOSMF workflows or other scripts that you might already have today, Ansible can already interact and invoke all of that automation, and also return and consume the results of that automation so that you can react and really enhance your automation today. And the key thing there also is that Ansible isn't intended to replace your existing automation, or nor is it intended to replace other tools, right? So things like system automation, which provides some of that more reactive, tighter sort of type of automation where it is able to monitor the system. Ansible isn't intended to replace that. Ansible is agentless, and that is one of the value points of using Ansible, which is a small footprint and easy to maintain across your managed nodes. But being able to put things like system automation and Ansible together, right? Being able to say, trigger Ansible based off of things that system automation maybe catches, or you have, profiles for, that's really where you get the benefits of both worlds here. And last but not least, probing the mainframe. And this is where, for one, Ansible does already a basic level of what's called fact gathering, which is collecting basic levels of system information that can be leveraged within Ansible playbooks. But obviously we can take that even further, right? Using Ansible to, again, interact with the various interfaces and logs that we have available to collect additional information, whether it be audit logs or security type of configuration, doing health checks and things like that. And our team also is invested in extending those capabilities from a ZOS perspective to be able to collect additional specific information through ZOS. So as you can see, there's a lot of potential that really opens up even more once you start introducing some of the capabilities from Ansible here. So I'm going to go ahead and dive into now how you can really get started here. That should be it in terms of slides. So let me go ahead and hop over to firstly talk about where you can find some of this content. So like I mentioned, we're distributing everything as collections, and where you can find some of that stuff here is in Ansible Galaxy, which is the open source community repository, IBM ZOS. So the collections are firstly delivered here in Ansible Galaxy. This is also where we deliver some of our beta content as well. Like I mentioned, our offering is the Red Hat Ansible certified content for IBM Z. And what certified means is that you also have service and support, and that is made available through a subscription to Ansible Automation Platform, which gives you access to Ansible Automation Hub, which is a similar type of repository, but again, behind that subscription requirement for Automation Platform. So as you can see here, you can see some of the various collections that we have available from System Automation, Core, IMS, CICS, ZOSMF, so on and so forth. Just to highlight some key things here that we're also going to be using is once you click into the core collection, you can see some of that content and some of the various capabilities that we have available. And most importantly, you can see our consolidated doc site here, which is one of the most important resources that you have available, because you can go in here and you can see not only some of the various requirements for both the control node, right, the Ansible versions that are supported, where you can download Python, and the SSH requirement that we have as well. But for the managed node as well, you can look at some of the requirements that we have there. So for example, the ZOS core collection. I'll mention as well, the ZOS core collection, I don't think I described this yet, is really the foundational Ansible collection that we have for IBM Z, which provides a lot of the base capabilities for interacting with ZOS. And you can see from the module perspective, we have some of these very low-level modules which allow you to, deal with data sets, deal with copying information to and from ZOS, while also handling some of the encoding intricacies that we have with the platform, being able to find data sets or find members within data sets and also interact with that data using line and file or block and file. Obviously, an important aspect is being able to work with JES and be able to submit, query, get output from various jobs, and we're able to do that as well as submit some of the basic commands that we need, such as operator commands, TSO commands, and things like that. I'll mention that, like I said, connection is established through SSH with Ansible, and everything operates under the context of the user ID that's making that SSH connection. So it's still all backed by RACF or whatever security product that you're using here. So Ansible does not bypass any sort of security policies that are in place here to be able to execute any of these things. So if, for example, a user, the ID doesn't have access to submit a particular command, it'll go ahead and fail just like you'd expect if you were submitting that command within the system console directly. So going back to what I mentioned about the requirements, you can go and see sort of the various requirements that we have for the different collections. And I'll highlight on the core collection, you can see, we are leveraging Python for ZOS, which is the IBM Open Enterprise Python for ZOS, as well as Z Open Automation Utilities, which provides some of those lower level capabilities and libraries for interacting with MBS from Unix system services. So there's a number of different command line utilities there and Python interfaces that product makes available. Now, both of these are available as packs downloadables for no charge, as well as optional service and support, which you can also get through Shop Z. I'll highlight here where you can actually find those. So firstly, if you want to get started for downloading ZOAU, you can download this here on the mainframe download site, where you can find a lot of other products as well. But if we just go ahead and search Open Automation, you can see, you can go ahead and find that and download that PAX file as well. Same goes for Python for ZOS. Like I mentioned, there's a free edition for the packs that you can download, as well as an SMPE installable that you can get through Shop Z. So that's how you can get some of the prereqs that you need on the ZOS side. And then on the control node side, essentially you'll need Python as well as Ansible, and depending on the platform that you're using, you can certainly, there are a lot of different options for how you can download Ansible and Python. You can, if you're on a Mac, you can use Brew, you can use pip, and same goes for Python as well. There's a number of different ways for you to be able to install some of that. So now let me move on to one of the other resources that I want to highlight today is the sample GitHub repository, where we have a number of different playbooks available. And this is, again, another way that we're providing Ansible content for the various products, and providing a way for users to be able to get up and running and have something for reference to be able to use, and really get hands-on with some of the modules and capabilities that we're making available. So this playbook repository also, I'll note, is open for contribution. So the intent here is that, we're trying to cultivate a very open community around Ansible. That again is one of the benefits for leveraging Ansible in general, is that it's such an open community and a lot of participants on a lot of other platforms as well. And we're looking to have that same type of participation from the Z side as well. So we've been doing a lot to cultivate that community and are looking forward to getting additional, we've been getting contributions from within IBM and are looking to get additional contributions externally as well. So all of that information on how to contribute, everything to consider when you're looking to develop playbooks and things like that is all highlighted here. And you can find that here in the various links that we have. We've got a contribution guidelines as well that folks can take a look once they're going down that road of contributing content here. But to highlight some of the content that we have available, as you can see, we've organize this in a way to highlight various sort of categories here, right? That makes sense and sort of in terms of getting started. We have some ZOS specific topics as well as some broader Z topics. Some examples that have been provided around provisioning OpenShift, as well as some ZHMC examples that leverage that ZHMC collection that we have available. But hitting on some of the ZOS topics, as you can see here, we're touching on some administration and basic operation types of use cases. And we'll actually dig into a couple of these, but just to see, again, these are all leveraging some of the core collection modules. And I'll go ahead and maybe just click into one of these so you can see the intent of the extent of what we have here. So they're pretty well documented, and the intent here is that they're all individual standalone types of samples, which you can run end to end on your environment. That'll also assume that you don't have any existing setup or anything needed there aside from the prerequisites. And you'll be able to execute these. And once they're done executing, they'll also clean up your environment as well, so you aren't left with any hanging artifacts or anything like that. So they're intended to be able to, and they're well documented, so you can sort of understand exactly what's happening and how you can. These are also intended to be used as a model as well, right? So once you get hands-on with these, you can start using these as examples yourselves to do some more other real tasks on your environment. So as you can see, some basic things starting up front, and then we start getting into some of the more intermediate or advanced types of use cases, right? Where we're using things like ZOSNet workflows or working with system automation, defining dynamic resources, and then talking about various subsystems like IMS, ZOS Kinetics, MQDB2, where we've got a number of different, provisioning type of samples, as well as application deployment or artifact generation types of samples, as well as one down here that we've got around interacting with SMPE and some of the GIM SMPE utilities to see how you can apply updates to some existing software that you have applied PTS and things like that. So again, a very valuable resource to come look through here. And let's actually dive into how you can get started. So this might be new for some folks as well who may be not familiar with Git, but hopefully this is helpful in getting started. So what I'm gonna go ahead and do is I'm gonna clone this repository here. And I'm gonna go into my editor, and this is VS Code. This is what I'm using as my local IDE. And I've already created a directory that's empty right now, but I'm gonna go ahead and clone this repository into here. Oops, git clone. So what that's gonna do is pull down that entire repository onto my local file system so that I'll have all those playbooks and samples available to me here. And I'll take just a minute here, and I'll go ahead and grab some water while that's going. Great. So as you can see now, on the left-hand side, it's now populated with all the various directories that we saw previously on GitHub. So I'll go ahead and hop into one of these. Let's see, I'll pick one of these ZOS concept ones. Copy, edit, submit. That's a good one. That one essentially is showing how you can, it's going to use a couple different modules, a copy module, line and file, and job submit. And what that's going to do is, one, demonstrate how you can copy a template from your local environment into ZOS, as well as manipulate that content. So what we're actually going to be copying over is JCL, right? And we're going to run a couple different commands here. I believe one of them is the uptime command, right, which shows just some of the system status in terms of how long it's been up, as well as the ps-a command, which is just listing some of the currently running processes. But what we're going to show here is actually we have a single JCL, but we're going to use this same JCL and modify it for running the secondary command. So like I mentioned, I just freshly cloned this, and let me demonstrate exactly sort of some of the files that need to be updated once you're getting started here. So the main thing here, firstly, is an inventory. And what an inventory is it describes the target managed node that you want to operate against here. So there's a couple of different variables here that I need to update, which is the Ansible host, which is going to be my host name. And then also the target user ID that I want to use, which is MVS ADN. I'll go ahead and save that. So a couple of variable changes there. And then what I'm also going to go over to is the host vars, which has a couple of different variables that we need to change. And again, I talked about the Python and ZOAU dependencies that we have, and that's exactly what we're going to be changing here. So what I need to point to is the location of my Python, and I happen to have that copied over here. I'm going to go ahead and paste that here. That's where I have Python installed. And this is also where I have the binaries for Z Open Automation Utilities installed. And that's it. That's all I need to update here. Everything else that we have, all the other variables files, are going to be leveraging variable substitution, for the Ansible Python interpreter, which points to the Python executable, as well as some of these other environment variables that we have, which are basically going to be set in that shell session that gets opened up once we establish that connection. All of this is also using variable expansion. So we don't need to update anything here. So again, we've updated these two, as well as these two as well. I'll also mention, we've also made these playbooks, some of the basic concept and administration playbooks, also easier to run in terms of having some prerequisite checks done as well. So as you can see, this is the main playbook that we'll be running that's going to be executing some of the tasks that we have, such as creating a temporary data set, copying that JCL over, performing the line-in file update and all that. But actually, we're not going to be running this playbook directly as you normally would. What we've done is we've also introduced a site.yaml playbook, which is actually going to check that you have the required dependencies available. And what are those dependencies? Actually, we have a runtime requirements file here that shows we have an Ansible version requirement of 2.9 or 2.11, as well as a particular core collection. Now, all of these requirements are documented on the README page, but if for some reason those were missed, when you run the site.yaml, that'll also notify you of any missing requirements. So just another way to make it a little bit easier when you're getting started and trying to run these for the first time. So we've made a couple of different updates there. Let's go ahead and run this playbook. And how we're going to do that is, actually, before I run the playbook, let me also mention how you typically install one of those collections, like the core collection. So I happen to already have it installed, which I can see here with the Ansible Galaxy collection list command, which will show the various collections that I have installed and the version. So you can see I have the ZOS Core, IMS, and ZOSMF collection, and this is the associated version there. But if I wanted to, for some reason, install it again or install a different version, what I can do is say Ansible Galaxy collection install, and a namespace and the collection name. And just using this, first off, will just automatically pull the latest GA version of that collection. Now, that's important to know because we do have beta versions available in Galaxy, and in order to be able to install those, you do require specifying the particular version. And how that's done is like this, where we say version 1.4.0 beta.1, for example. And that's how it'll be able to pick up some of those specific versions that are available as beta. So I've already got that installed, so I won't go ahead and run that, but now I'll go ahead and run the playbook. So what I'm specifying here is the inventory. Let me see, what directory am I in? There we go. Let me go ahead. There we go. I inventory, and I'm specifying that I want to run against that inventory file, and site.yaml is a playbook that I want to run. So as you can see, it's starting off with the requirements check, and now it's going to go ahead and create that temporary data set there. And I'm going to go ahead and also pop over here so you can see that it is actually performing some function here. And so you can see it's actually copying a PDS member prefix with onvs-adm, which is my user ID dot so-and-so, which is a temporary data set name. If I go ahead and browse that, you can see that has been allocated there. And let's go ahead and see what else is going on. So it's edited. It's already actually submitted. Let me see. Oh, so it's copied the file over, and it submitted the initial JCL. That's, let's see, this one is running the PS command. And then we were getting that, we've got the response there. And then we actually also had already used the line-in file to update that. And we've got uptime as well, which is also run here. So you can see you get the same type of output that you'd expect to see, if you're going into SDSF and browsing that job output, and that gets returned. And then upon completion of this, that data set gets deleted. So we should see, if I come back here, let me get back out and refresh, and you can see that that data set has been deleted. And if we go over to SDSF, you can see we have a couple of JCL that had run PSA and uptime there. So that's just basic running of this playbook. But now let's say, what if I wanted to, take a look at that JCL within that data set, or I wanted to, prompt for whether or not I wanted to actually delete that. What would we be able to do, and how easy would it be for me to edit this, right? So let's go ahead and look at how we would do that. So as we can see, right, so we're submitting that last JCL for uptime here, getting that response, and then deleting that data set. But what I want to do is actually, before deleting that, I want to prompt prompt the user on the command line whether or not I actually want to delete that. And what we're going to do is add a pause here. So prompt for delete. And now we do that. So pause, what pause is, this is known as a task, which is made available through an Ansible module. So what I can do is say prompt and what I actually want the message to be. complete data set. Yes or no, which is what I want. And then what I'm going to do, every single Ansible task that you invoke returns a JSON response. And you can register that response to a variable so that you're able to interact or dig into some of the fields of that response and do some conditional checking, which we're going to do here. So what I'm doing is I'm taking that JSON response from this prompt and I'm registering it as a variable called confirm delete. So now that I have that available, what I want to do is I want this to be conditional, and it's as simple as saying when, right? When confirm delete user input. So like I mentioned, user input is a particular field, and I need to classify that as a Boolean because we're using yes or no. Ansible only really recognizes two particular arguments as true Booleans, which is true and false with a capital T or F. Any other options, 0, 1, yes, no, lowercase, true, false, uppercase need to be qualified with that Boolean classifier there. So and I'll actually go ahead and show, since we're talking about the contents of confirm delete, kind of what that looks like as well, and show you how easy it is to also print out some of that. And what we're going to do here is actually just do debug variable confirm delete. So that's going to print out the contents of that variable as well. So those are the few additions that I made. Let's go ahead and run this again. And for anyone on the call, if there's any questions, feel free to go off mute at any time, or if there's any in the chat as well. Let's see. Okay, don't see anything in the chat just yet. So the JCL are being submitted. Okay, great. So now we saw this prompt, right? And so this time around, I'm going to say no, that I don't want to delete it, right? And as you can see, when I said no, it went ahead and for that delete dataset task, it said and notified that it was skipping it. So let's go ahead and double check here. And we can see we've got the returns for PSA and uptime that ran, as well as that remaining temporary data set here. And I can go ahead and browse that, and we can see we have the two JCL available there. And like I mentioned, we also decided to print out the JSON response of that confirm delete, which you can see here. And we were leveraging that user input field in that conditional. So let's go ahead and take a look at another. So we talked about kind of working with JCL and data sets. And let's go ahead and take a look at one more different, I think more critical example as well, which is around operator commands. Let me first off open this up in the terminal here. And so let me go ahead and let's see, let's take a look at what we're doing here. So I'll note that this this playbook looks a little complicated, but the only reason it looks like that is because we're using highly qualified and detailed variable names and descriptions here. As you can see, result DOS action pre-query is one single variable. So we've got a number of them here, but that's intended so that you're sort of able to read through this and kind of follow exactly what's happening. But let me go ahead and go to the README. Which shows that we're going to be using the operator action query to query for any WTOs that are available on the system log and submit some ZOS operator commands as well. And looking through, let me go ahead and close some of these. What we're going to be doing is actually querying for any available messages that have this particular message, specify operand, something that we can respond to. And if not, we're going to also just simulate a dump. So what we're going to submit is a dump command to get a system dump, get that response back, and then reply back to that with an end down here. So you can see we get the reply number, and then we're going to respond back to that, and then we're going to check to make sure that that was successful. We're again checking for any additional messages that are left there. So again, just quickly, some of the updates that I need to make here. Again, this is a fresh playbook. That, let me go ahead and change the host vars here, which I have saved. And that's it. So let's go ahead and run this. Ansible playbook -I, same basic command here. Inventory site.yaml, right? Again, to check the prerequisites. So all of this previous output is just doing some of that dependency checking here. So you can see now we're actually querying for some messages, and I'll actually show that. So here, let's go here. You can see I've got a few different WTOs available. I've got an IMS system also running here. So that you can see it actually detected that we've got an IMS control region as well as IMS connect already existing, but it did not find when it filtered for this particular message ID and command here. So it's doing that check, right? If not, it's going to run the dump command, which you can see here. And actually you can see here that it's now being shown. So it's continuing to run. So again, it queries again for the WTOs, and now you can see the two existing that I had, as well as a new one that we triggered with the dump command. And then it's filtering for that specific one, right, from this JSON response. Again, doing a similar type of variable registration and manipulation to get the appropriate response and the fields. So it's going to, in particular, pick the message ID in order to be able to submit the operator command in order to end that dump. So you can see the reply here in the response to that is end, and then it goes back and checks for the that message again, in which it does not find it. So again, just another example of how you can, again, leverage some of the content that we have from the ZOS core collection. We've seen submitting data sets using line and file, ZOS copy, and now ZOS operator as well. And in terms of some of the command types of modules, and we have TSO command as well, which you can also run various rackf commands or any other types of commands that interact with some other products via operator or TSO commands. And if you're looking to run any sort of shell commands or other tools that live in USS, such as like DB2 command line processor, right? That we have the shell module available through Ansible directly with the Ansible base engine to be able to do some of that, which is just another easy way of running Unix-based commands. So the last thing I want to show here is actually an IMS-based type of use case. And this is around, again, first off, highlighting the IMS collection that we have available. So let me hop back over here just to quickly highlight some of that. So we do have an IMS collection that allows you to do, that wraps some of the various tools that we have, such as interacting with the IMS catalog, submitting IMS type 1 and type 2 commands, as well as generating sort of application and database artifacts, such as the database descriptor, the program specification block, and the application control blocks, right? The PSB, ACB, and DVDs, and also submitting some DVRC commands as well. So similarly, you have similar types of capabilities with the Kix collection, which interacts with the CMCI interface. So you're able to do a lot of interactions with CSDs and other commands that are made available and APIs through the CMCI APIs as well. So let me hop back over here, and what we're going to talk about is one of the samples that we have, which is around COBOL, IMS COBOL application deployment. So, and I'm going to start off with sort of like a high level use case where, you know, say I'm in, let me go ahead and close these out here. I'm an IMS application developer, and you know, I need a first off an IMS region to and application region and the control region to be able to, you know, test out a particular COBOL application. And I know my enterprise, they also have Ansible Tower available to be able to spin up some of these environments, which I'll also go ahead and show here. So what I've done, I'm going to be logging into Ansible Tower. And like I mentioned before, let me just quickly give a brief overview of what you're seeing here. So this is Ansible Tower, which again is the one of the key tools to be able to monitor not only your target nodes, all your different hosts that you're running Ansible automation against, but also make available all your different Ansible playbooks and be able to share these things and put levels of access control and protection, and really scale up how you want to make these available. So first off, to highlight, you know, all of these, you know, these are all leveraging the same types of Ansible playbooks that we saw. Right now, how you get these into here is you have what are called projects, which all connect to, you know, whether it be a GitHub repository, local Ansible playbook projects or whatnot. That's how you can import some of these projects, which then you can create what are called job templates in Ansible Tower. Now, these are all based on the various different playbooks that we just saw. So I can have a playbook for submitting a set of operator commands to do a particular thing, or submit jobs, or anything else that I need to do. So what we have from the IMS perspective, as you can see, I've got a number of different things here for provisioning an IMS control region, or deploying the COBOL application, which I've already performed ahead of time. So what I've done is I've actually provisioned an IMS TMDB, which you can go to completed jobs, and you can see this is what the output looks like when you're running Ansible automation through Ansible Tower. So similar type of look and feel in terms of at least the output that you get on the right-hand side here. But what you can also do is you can actually click into some of these fields and actually get more detailed information. Again, all of the JSON response that you have from each of the tasks, that's all saved here. All the logs are saved within Ansible Tower, and that's available for inspection later on. And then all the other information that you have associated with the job template that was run, you have full visibility into exactly who ran what and when based on what credentials, and all that, and you're able to dig into some of that information here. So I've already provisioned an IMS control region. And then what I've also done is, and let me actually go ahead and show the my view. This is a view that shows exactly the job templates that I have available, as well as some of the jobs that I've run in the past. So I've also run this deploy COBOL application, which essentially took a COBOL application, which I had specified here. You can see the program and tran name as iBackSum. But what that did at a high level was deploy the application artifacts, such as the COBOL application did the compile and link, as well as the PSB and DVD source for my application, and generated the appropriate artifacts in order to load that into IMS. So I've already done that ahead of time. So what you can see here, let me actually clear this. So let me go ahead and invoke that IMS application here. Add back some. So I've done that. You can see that I've sent that into the control region. Let me actually go and look at. So I have this IMS1 MPP2, which is my MPP region for that COBOL application. And if I inspect that and I go down to the bottom, I can see that I've issued, I got the response back from that application, so that IBAC sum, what that is bank account summary. So you can see we've got the summary for that bank account here, including the balance, account ID, et cetera. And you can see that. So for example, if I'm an application developer, I'm making changes to this application, I want to redeploy, right? I can do that easily. Now, what I've got is I've got all of these playbooks available, which my IMS system programmer has made available to me to be able to do this in a controlled manner, such that the system programmer has confidence in the task I'm running, and I actually don't need to go ahead and try and invoke some of those utilities myself through JCL or some other script. So what I can do is I can go back to the templates and redeploy this application. And some of the things that we also have available to us through Ansible Tower is, I mentioned how we have prompting, we have some additional things available such as surveys, which allows the user who's consuming this Ansible playbook to be able to now provide variable input, right? So again, you get a much more control as you're putting your Ansible playbooks within Tower here. So again, that program name is IBACSum, which happens to have the same transaction name. And then I also have triggers for whether or not I actually want to generate or regenerate some of those application artifacts. So a dbgen is associated with the restructuring of how I want to my applications to access the database, and I didn't make any changes there, so I'm going to say that's false. But I do want to update some of the other application artifacts, and I'm going to choose not to reload any test data because we've also done some of that, or we have some of that associated with this application. So I can go ahead and click next, and it gives me a brief preview of what those variables that are actually being passed in and being used by the Ansible playbooks look like, also the inventory that I'm going to be running that against. So I'll go ahead and launch that. And once you launch it, it goes ahead and opens up this page where you can see the progress, just like what we saw in my local IDE and VS Code of running this Ansible playbook. So that'll go ahead and run. That'll just take a few minutes. But while that's running, let me actually go back to VS Code here and actually talk a little bit about what's happening here. So this is, again, this is another sample that we have available in our sample playbook repository. So if you're interested in taking a look, you can take a look at that there, and you can see we're leveraging both the core and IMS collection here. And like I mentioned, we're doing here's some of the variables for that we saw in the survey for triggering some of the application artifact generation. So these are all default values, and when we specify them in the survey, they're overriding what we have here. But we're doing the application artifact generation. We're making sure that we're checking for the appropriate runtime libraries. We're then recompiling and linking that COBOL application. This is where we have that section for reloading the data, which we're skipping over, right? Because like we said, we chose not to update the data. So again, similar to the conditional that we saw earlier in the previous example, we're checking here whether or not we want to update the data, and that was set to false. And then at the end here, we're refreshing all of our IMS resources to make that application change live. Let me go ahead and dig into what you're seeing here is a number of different roles, and you can think of these as various different classes that we made available and designed in a way so that you can reuse these roles in a number of different playbooks. So, the benefit of this is that these are all reused against some of these other playbooks that we have, such as deploying or deprovisioning that application and tearing things down. So if you can see the initial deploy, it's using some of the same types of roles here. It doesn't have a conditional for loading data because we certainly want to do that, right, during that initial deployment. But for redeploy, that's where we have some options here. So again, just talking a little bit about some of the flexibility you have when you're actually designing some of your playbooks and roles. So let's take a look at the role for refreshing the IMS resources here. And as you can see, what we're doing is we're leveraging the IMS command module, right? And what this allows us to do is run, again, type 1 and type 2 commands from IMS. So you can see we're running the type 2 command for updating the TRAN, which essentially is stopping the TRAN and stopping the program. And then you can see down here, we're running actually the IMS type 1 commands, equivalent to those for starting. So again, similar, just showing some of the flexibility we have with some of our modules here. And similarly, I think we're doing the same when we go over to, talking about some of the regions. We have that in another separate role. So you can nest how you invoke some of these roles. You can have roles that call other roles, or nested tasks and things like that. So similarly, we're calling the stop region command and leveraging some of the variable expansion and substitution that we have available with Ansible as well. So some of this information is set by the system programmer, right? So these are all not things that the developer or myself, needed to change or needed to provide as I was provisioning or deploying. These are all things that were preset by the system programmer, so that I'm not provisioning anything under the wrong SSID or have incorrect application region attributes or the wrong TRAN or TRAN classes and things like that here. So let's go ahead and go back and see, like we said, so this took 2 minutes and 52 seconds to run. And again, you can see some of the message output. Let me go ahead and go to one that you can see for the IMS type 1 command for the start, shows the start command completed, and exactly what command was run and which IMS plex it was routed to. And then if we go over to here, you can see that we did have a couple of JCL that ran, and the application region IMS1 FTP2 did go down. So if I go back out here, I should see that there's a new MPP region. And if I check, we can see that there is no application output there since it was a refreshed region. So at least we have some confirmation that that region was indeed refreshed. So again, that's a little bit more in-depth and more advanced type of use case that I just showed, where we're now talking against particular ZOS middleware and using one of the middleware collections, right, for IMS. And we do have some things available, like I said, for Kix and some sample playbooks for ZOS Connect and DB2 as well. So I definitely encourage folks to look at that. I'll just hop back over to the charts here just to close up on some of the other resources that we have available if you want to get started. If you're not looking to use the sample playbook just yet, or you're not ready to don't have any of your environments set up, we do have a Z trial available, which provides you an IDE to use, just like what we showed, VS Code and a backend ZOS to be able to run some very basic scenarios that we have here. Similarly, so you can register for that and you'll get access to an environment to be able to test on. If you're looking to play around more with the Ansible automation platform, there is a 60-day subscription free trial that you can get as well. That does require you to provide your own infrastructure to deploy that automation platform. into a RHEL instance. So a little bit more advanced there, but if you're interested in getting hands-on with automation platform, that's a good option. Like I mentioned, we talked through the sample playbook repository as well. So that's available here for you to look at. And then some other resources that we have. We've got a community, our Ansible for IBM Z community page, which has a lot of different resources in terms of blogs that we put out, discussion area, and as well as different upcoming events and talks that we might have, as well as videos and other resources. So definitely check that out. And here's just another page as well, finally, just for some additional resources and links. So aside from that, there's definitely several other Ansible sessions throughout the conference here. We've got a couple other coming up on the 9th and the 11th. One talking more specifically about kicks by Stuart Francis, and then we've got another one more doing some more operational type of prog level examples with Bill Pereira. And if you didn't catch, on November 1st, Dan Jess had a really good presentation talking about some key customer use cases in a little bit more detail. So if you didn't catch that, you can definitely take a look at the recording when that's available as well. And don't forget to submit your session feedback as well. We'd definitely appreciate that so we can provide more good content for all you folks here. And yes, definitely become a member of GSC UK.
Thank you so much. Okay, great, thank you. Yeah, so the session code is 4AQ, so please make sure you go and fill out some feedback. Thank you very much, that was a really good session. I think there's plenty of good ways for people to easily get started with having a try with this. I didn't realise that we had Z trial with Ansible, so that's good to know. Cool, so thank you very much. We've got a half-hour break now, so next session will be at 5 o'clock. So thank you. See you all at 5.
Great, thanks. Thanks, everyone.